Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths Practice Questions on the surface area of a frustum. If you need any extra help on the surface area of a frustum, if you go to Corbettmaths and go to the Videos and Worksheet section and scroll down to video number 314A, there's a dedicated video tutorial there on the surface area of a frustum. Alternatively, you can scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, let's have a look at our first question, question number 1. So question number 1 says a frustum is made by removing a small cone from a larger cone. So as you can see, we've got this larger cone and then a smaller cone's been removed, so we're left with this frustum here. And we've been asked to calculate the surface area of the frustum. So we want to find the surface area of this frustum. Now in terms of this frustum, it's got the circular face on the top, it's got the circular face on the bottom, and then it's got the curved face going around the outside. So if we want to find the surface area of this frustum, we're going to need to find the area of the two circles, that's the circle on the top and the circle on the bottom, but also the area of that curved face. To find the area of the two circles, that's quite straightforward. We're going to be using pi r squared for that. So we're going to do pi times the radius squared for the circle on the top. So it'll be pi times 12 squared. I'm just going to write that down, pi times 12 squared. That's the area of the circle on the top. In terms of the area of the circle on the base, that's going to be pi times the radius, which is 24, and then squared. And that'll give us the area for the circle on the base. And then we need to find the area of that curved face. And to find the area of that curved face, well, let's consider the cone. If you want to find the surface area for cone, you do the area of the base plus the curved surface. And the area of the curved surface for the cone is found by using the formula pi RL. That's pi times the radius times the slant height. So if I wanted to consider this whole cone and I wanted to find the area of that curved face on the outside, what I would do is I would do pi times the radius times the slant height, which would be 30 there. But what I'm going to do is I'm going to work out the area of that curved face. I'm going to work out the area of the curved face for the cone that's been removed, and then if we take them away, what's left will be the area of that curved face, so the frustum. So let's work that out, okay? So in terms of the area of the curved face for the whole cone, we would do pi times the radius of the base of the whole big cone would be 24, times the slant height, which was 30. We would then do subtract, we're going to work that out, and we're going to subtract what we get when we work out the area of this curved face here. So that's the curved face of the smaller cone that's been removed. So that'd be pi times the radius of its base, which is 12, times its slant height, which is 15. So we're working out the curved face of that whole cone, this whole curved face there, and then we're working out the curved face of the smaller cone that's been removed, and then we're taking them away. So let's work that out. So if we do on our calculator, pi times 24 times 30, that would be the area of that curved face of the whole big cone. And then we're going to take away the area of the curved face on the cone on the top, and we find that by doing pi times the radius of its base, which is 12, times its slant height, which is 15. And when we work that out, we get an answer of 540 pi centimeters squared, or as a decimal, it'd be 1696.460033 centimeters squared. So that's the area of that curved face of the frustum. Now let's find the area of the circle on the top, which will be 144 pi. When we do pi times 12 squared, that's going to be 144 pi. So I'm just going to type into my calculator, pi times 12 squared is 144 pi, or 144 pi, or as a decimal number, 452.38934 and so on centimeters squared. So that's the area of the circle on the top of the frustum. Now let's find the area of the circle on the base of the frustum. So we're going to do pi times 24 squared, and that's equal to 576 pi, or as a decimal number, that's equal to 1,809.557368 centimeters squared. So that's fantastic. We've now found the area of the circle on the top of the frustum, the area of the circle on the base of the frustum, and the area of the curved face going around the outside of the frustum. And if we just add them all together, that'll give us a total surface area of that frustum. Now, what I can do is I can do it in terms of the decimal numbers. I could type all this in, plus, and then all that, plus, and then all that. Or in this case, I'm just going to work in terms of pi whenever I'm adding these together. So I'm going to do 540 pi plus 576 pi plus 144 pi. I could if I wanted to type them all in, but that's just a little bit quicker. So if I do 540 pi plus 576 pi plus 144 pi, that's equal to 1,260 pi centimeters squared. So that's the total surface area in terms of pi, and as a decimal number, if I convert that to a decimal on my calculator, that gives me an answer of 3,958 358.406,744 centimeters squared. So that's the total surface area of the frustum, 3,958.406,744 centimeters squared. And that's it. The question didn't ask us to round it to any particular accuracy, but I could perhaps round it to one decimal place here to be 3,958.4 centimeters squared. And that's it. That's our answer. Okay, let's look at our next question, question number 2. So question number 2, we've got another frustum here, and it says a frustum is made by removing a small cone from a larger cone. So we've got this larger cone here, and then we've got the smaller cone that's been removed, and then what's left is this frustum. And then the question says, find the surface area of the frustum. So what we're going to do is we're going to find the area of the circle on the top of the frustum, the area of the circle on the base of the frustum, and then this curved surface area. So in terms of the circle on the top, we're going to do pi times the radius, which would be, well, the diameter is 4, so the radius would be 2 squared. And if we do pi times 2 squared, that's equal to 4 pi, or as a decimal number, 4 pi is equal to 12.5663761. And it's important not to round these because we're going to be adding these all up at the end, and that's centimeters squared. So that's the area of the circle on top of the frustum, and just remember the radius of that circle was 2. Okay, now let's find the area of the circle on the base of the frustum. So we're going to do pi times the radius. Well, if the diameter is 16, the radius would be 8, so 8 squared. And if we do pi times 8 squared, that's equal to 64 pi. And as a decimal number, that would be equal to 201.0619298 centimeters squared. So that's the area of the circle on the base of the frustum. So this is fantastic. We've now got the area of 2 of the faces. We now just need to find the area of the curved face. And to find the area of the curved face, we're going to consider the whole cone. And we're going to do pi RL to find the curved surface area of that cone. Then what we're going to do is we're going to do pi RL to find the surface area of the cone that's been removed. And then if we take them away, what's left will be the area of the curved face of the frustum. So let's work that out. So for the whole big cone, we would do pi times the radius of the base, which would be 8, times L, the slant height. I'm just going to write it down, pi RL. So the slant height. Now the slant height is a distance from here, the top, all the way down the side of the cone to there. Now in terms of this distance, well, if that's 2.5, this would be 2.5. And if we do 7.5 plus 2.5, if we do 7.5 plus 2.5, that's equal to 10. So that means the slant height is 10 centimeters, the whole way from the top down the side of the cone. So that would be times by 10. So that's going to be 80 pi when we work that out. And then we're going to take away the curved surface area of this cone. So we're going to find the area of that curved face of the cone. So we're going to do pi times the radius of its base, which is 2, times its slant height, which is 2.5. And when we work that out, we'll get 5 pi. And we'll do 80 pi, take away 5 pi, and that's equal to 75 pi. Or you can use your calculator and do pi times 8 times 10, subtract pi times 2 times 2.5, and that's equal to 75 pi centimeters squared. Or as a decimal number, 235.619449 centimeters squared. So that's fantastic. We've now got the area of the circle on the top of the frustum. We've now got the area of the circle on the base of the frustum, and we've now worked out the area of the curved face of the frustum. And now let's add them all together and get the total surface area of that frustum. Now we could work with the decimal numbers if we wanted to, but I'm going to use our answers in terms of pi just because it's a bit easier to type into my calculator. So I'm going to do 4 pi plus 64 pi plus 75 pi. So 4 pi plus 64 pi plus 75 pi is equal to, well, let's do it on our calculator, 4 pi plus 64 pi plus 75 pi is equal to 143 pi centimeters squared, or as a decimal, I like to change it to a decimal at the end because it just makes a bit more sense to me, 449.2477495 centimeters squared. And if we wanted to give our answer perhaps to 2 decimal places, it would be 449.25 centimeters squared to 2 dp. That stands for 2 decimal places. And that's it. That's the surface area of that frustum. Okay, let's look at our next question, question number 3. Okay, so question number 3. Question number 3 says a frustum is made by removing a small cone from a larger cone. And we've been asked to calculate the surface area for this frustum. So we want to find the surface area for this frustum. Now this one's a little bit different than the ones we've had so far because this time we don't have the radius or the diameter of the circle on the top of the frustum. So we're going to have to work that out. So whenever you deal with frustum questions, it's quite important to realise that whenever you look at the smaller cone and the larger cone, they will be mathematically similar. So they're enlargements of each other. So if we go back to the first question, if we have a look at the smaller cone and the larger cone, so the smaller cone had a radius of 12 and the larger cone had a radius of 24. And you'll notice there that the radius of the larger cone is double the radius of the smaller cone. Now let's look at the slant heights. The slant height for the smaller cone was 15 and the slant height for the larger cone was 30. And again, that's double it. So the scale factor of enlargement there will be 2. So they're mathematically similar, that smaller cone and the larger cone. Let's have a look at question number 2. So question number 2, if we have a look at the diameter of the smaller cone was 4. The diameter of the larger cone is 16. So that's 4 times larger. If we then look at the slant heights, the slant height for the larger cone is 10 centimeters, the 2.5 plus the 7.5. And the slant height for the smaller cone was 2.5. So again, that's 4 times larger. So the scale factor of enlargement there is 4. So if we have a look at this cone here, we have got the slant height for the smaller cone being 7 and the slant height for the larger cone being 20. And to get the scale factor of enlargement, we just need to divide the slant height of the larger cone by the slant height of the smaller cone. And what that means, we would do 20 divided by 7, which is 20 sevenths. So that means that the scale factor of enlargement is 20 sevenths. If you take 7 and you multiply it by 20 sevenths, that's equal to 20. So that would be equal to 20, because if you times it by 20 sevenths, that's equal to 20. So that means if we want to work out the diameter of the smaller cone, we just need to take the diameter of the larger cone, which is 16, and divide it by 20 sevenths, because obviously it's smaller. So if we do 16 divided by 20 sevenths, that's equal to 5.6. So 5.6. So that means the diameter of the smaller cone is 5.6 centimeters. And that's fantastic, because now we can work out the surface area of the frustum. So that's great. We've now worked out the diameter of the base of that smaller cone, which will be the diameter of the circle at the top of the frustum. So that's fantastic. We can now work out the surface area of the frustum. So let's do that. So let's work out the area of the circle at the top of the frustum. So it's going to be pi times the radius, which would be 2.8, because 5.6 divided by 2 is equal to 2.8. So pi times 2.8 squared. And that'll be the area of that circle. So if we do pi multiplied by 2.8 squared, that's equal to 196/25 pi, or as a decimal number, 24.6300864 centimeters squared. So that's the area of the circle on the top of the frustum. The area of the circle at the bottom of the frustum would be pi times the radius, which would be 8 squared. And if you do pi times 8 squared, that's equal to 64 pi, or as a decimal number, 201.0619298 centimeters squared. So that's the area of the circle on the top of the frustum and the area of the circle on the base of the frustum. Now we need to work out the area of the curved face of the frustum. So it's going to be, if we work out the curved surface area of the cone, the top cone, and the curved surface area of the smaller cone, then we can take them away to find the area of that curved face. So for the larger cone, we would do, remember the formula for the area of the curved face of a cone is pi RL. So it's pi times the radius of the base times L, which is the slant height. So for the larger cone, we would do pi times the radius of the base, which is 8, times the slant height of the larger cone, which is 20. So that'll be 160 pi. Subtract, and then for the smaller cone, we're going to do pi times the radius of the base, which is 2.8, times the slant height, which is 7. And then if we work that out, that'll then tell us the area of that curved face. So let's do that. So we're going to do pi times 8 times 20, subtract pi times 2.8 times 7. And that's equal to 441.0796086 centimeters squared. So that's fantastic. We've now got the area of the circle at the top of the frustum, the area of the circle at the base of the frustum, and the area of the curved face of the frustum. And now we just need to add them together, and that'll be the total surface area of that frustum. So let's do that. So let's take the 24.63 and so on, and you're going to type that all into your calculator, plus the 201.0619 and so on. And again, we want to type all that into our calculator, plus the 441.0796 and so on, and then press equals. Okay, so this is already on my calculator display. I've just worked it out. So plus 24.6300864, typing it all in, plus 201.0619298. And when we press equals, we get an answer of 666.7716 and so on centimeters squared. And I'm going to round that to 2 decimal places. So to 2 decimal places, that'll be 666.77 centimeters squared to 2 decimal places. And that's it. Okay, let's look at our next question, question number 4. So question number 4, here we've got a frustum, and we've been asked to find the total surface area of this frustum and to leave our answer in terms of pi. So this question is a bit different than the ones we've looked at so far because, one, we don't know the height of the original cone. It doesn't actually show us. If we look at the previous ones, we've had the bit that's been removed showing what's been removed, but here we don't have the bit on the top there. But also it says in terms of pi, so we're not using a calculator for this question, so I'm just putting the calculator down. Okay, so the first thing I want to do is if I want to work out the surface area of this frustum, I could work out the area of the circle on the top of the frustum. That's quite straightforward. Pi times the radius, 10 squared. We can work out the area of the base of the frustum by doing pi times 40 squared, and that gives us the area of the base of the frustum. And then we would need to find the area of the curved face of the frustum. And to do that, it'd be quite useful if we knew the slant height for the original cone. So let's actually put a little dot here, and let's pretend that's the top of the original cone, like so. And it'd be great if we knew that slant height. So what we're going to do is we're going to call this x, okay? The distance from here to here, I'm going to call that x. So the slant height for the smaller cone that's been removed. Okay, so we want to work out this slant height because if we can work out this slant height, we could use pi RL to work out the area of the curved face of that smaller cone at the top. And then we could use pi RL to work out the curved surface area of this larger cone. And then we can take them away to find the area of that curved face of the frustum. So let's do that. So in terms of finding out what this length is, now if we have a look at the radii, the radius of the smaller cone is 10 centimeters. And the radius of the larger cone is 40 centimeters. That's 4 times greater. That means that if we look at the two cones, the smaller cone and the larger cone, the scale factor of enlargement is 4. Remember, they're mathematically similar. So that means the scale factor of enlargement here for those two cones would be 4. To get from 10 to 40, we're timesing by 4. That means if we times this unknown slant height, x, by 4, it'll give us the total slant height. So that gives us an equation. If we take the x and we times it by 4, so 4 times x, because the scale factor of enlargement is 4, and if you do 4 times the smaller slant height, that gives us a total slant height. So 4 times x would be equal to x plus 60, because the scale factor of enlargement is 4. So 4 times x would be equal to x plus 60. Okay, now we can solve this equation. If we take away x from both sides, so take away x and take away x, we're going to get on the left hand side 3x, and on the right hand side we'll be left with 60. And then we could just divide by 3 and get that x is equal to 20. So it means that x is equal to 20 centimeters. So that's fantastic. We've worked out what that slant height is for that smaller cone. Okay, so I'm just going to change colour ink here, and I'm now going to work out the area of the circle on the top of the frustum, the area of the circle on the base of the frustum, and then the area of that curved face. So for the area of the top of the frustum, we're going to do pi times 10 squared, and pi times 10 squared is 100 pi centimeters squared, or as a decimal number 314.1592654 and so on centimeters squared. So that's the area of the circle on the top of the frustum. For the area of the base of the frustum, we're going to do pi times 40 squared. So it's going to be pi times 40 squared, and that's equal to 1600 pi, or as a decimal number 5026.548246 centimeters squared. So that's the area of the circle at the base of the frustum. Now we just need to work out the area of the curved face. And to do that, what we're going to do is we're going to work out the area of the curved face of the smaller cone, the larger cone, and then take them away. So for the larger cone, we would do pi times the radius of the base, which is 40, times the slant height, which is 80. And then we're going to take away the curved surface area of the smaller cone, which would be pi times its radius, which is 10, times its slant height, which is 20. Okay? And when we do that, we'll find the curved surface area of this frustum. So pi times 40 times 80, subtract pi times 10 times 20 is equal to 3000 pi. Or as a decimal number, that's equal to 9,424.777961 centimeters squared. And that's great. So we want to find the total surface area of the frustum. Okay, now at this point here, I've just remembered that this is a non-calculator question, okay? So at this point, I was about to add up the 314.59 and so on, the 5,026 points and so on. But actually, let's just go back and say if this was a non-calculator question, what would we have done differently? So I'm just going to rub that out, I'm going to rub that out, and I'm going to rub this bit out down here. Okay, so we didn't have a calculator, and then if I was doing this question without a calculator, I would do pi times 10 squared. 10 times 10 is 100, so that's 100 pi, so we'd leave it in terms of pi. Here we're going to do pi times 40 squared. 40 times 40 is 1,600, so that would be 1,600 pi centimeters squared. And here, so without a calculator, we would do 40 times 80, which is 4 times 8 is 32, and then 2 zeros, and then we put the pi on the end. And then we would take away 10 times 20 is 200, and then pi, and then 3,200, take away 200 would be 3,000 pi. Okay, so we would do all that obviously without a calculator. Now we just need to add them together to find the total surface area of the frustum in terms of pi. So we're going to do 3,000 pi plus 1,600 pi plus 100 pi. So let's write that down. So we're going to do 3,000 pi plus 1,600 pi plus 100 pi. And that's equal to 4,700 pi centimeters squared. And that's it. And that's our answer. Okay, let's have a look at our last question, question number 5. Okay, so question number 5. Question number 5 says, shown below is a frustum of a cone. So we've got this frustum of a cone, and we've got the radius of the circle at the top of the frustum, which is 21 centimeters. We've got the radius of the base of the frustum, which is 35 centimeters. And then we've got the perpendicular height. The height of the frustum is 4.8 centimeters. And we've been asked to find the surface area of this frustum. Okay, so there's a few different things that are different about this question than the ones we've looked at so far. One, we don't know the slant height. So let's work out this slant height. I'm just going to call it y, okay? Because if we can work out this slant height, that'll then help us work out the slant heights for the two cones, the smaller cone and the larger cone. Okay, so that's y. And what I'm going to do is I'm going to make a little right angle triangle here. I'm going to make a little right angle triangle where we have got a line going straight down there to the radius, and again going across. And in terms of this right angle triangle, if this is 21 centimeters and this is 35 centimeters, this part here must be 14 centimeters. That must be 14 centimeters because 21 plus 14 would be 35. So that means that's 14 centimeters. And we know the height of it is 4.8 centimeters, 4.8 centimeters. So we can use Pythagoras' theorem to work out what y is. So let's do a little sketch of that right angle triangle and work out y. So I'm just going to get my ruler and pencil, and I'm going to just draw that little right angle triangle there. So that's a little right angle triangle. We have then got our right angle. That was 14 centimeters, because remember 21 plus 14 must be 35, and the height of it is 4.8. And then we're going to use Pythagoras' theorem to work out y. So let's do that. So a squared plus b squared equals c squared. A squared, that's going to be 4.8 squared, plus b squared, which is 14 squared, is equal to c squared, the longest side squared, which is the hypotenuse. So that's going to be y squared. And then on our calculator, let's do 4.8 squared plus 14 squared. And that's equal to y squared, which is 219.04. And then if we square root that, we get an answer of y would be equal to 14.8. So that would be 14.8 centimeters. So that's great. We've now worked out the slant height is 14.8 centimeters. Okay, now what I'm going to do is, like the previous question, I'm going to do a little top to where the original cone would have been, and then we're going to do a little dashed line down that way and down that way. Because in terms of this frustum at the base now, we can work out the area of the circle at the top of the frustum, the area of the circle at the base of the frustum, and in terms of the area of the curved face of the frustum, what we're going to want to do is to work out the curved surface area of the top cone, the curved surface area of the whole cone, and then take them away to get that surface area, that curved surface area of this frustum. So in terms of the larger cone, it would be great if we knew what this distance here is, the slant height of the smaller cone that was removed. So I'm going to call that x. And let's find what the scale factor of enlargement is. So let's have a look at the two radii, and if we divide 35 by 21, that'll give us a scale factor of enlargement for the two cones, the smaller cone and the larger cone. So if we do 35 divided by 21, that's equal to 1.6 recurring, or 1 2/3. So if you multiply by 1.6 recurring, that'll then give you the 35 centimeters. So if you multiply the length of the radius of that smaller cone by 1.6 recurring, the scale factor of enlargement, you get the 35 centimeters, the radius of that larger cone. So what that means is that if we multiply this x, the slant height of the smaller cone, by 1.6 recurring, that'll give us a slant height for the whole larger cone. So that means we can form an equation that x multiplied by 1.6 recurring, so 1.6 recurring x, multiplying that by 1.6 recurring would be 1.6 recurring x, is equal to the slant height of the larger cone. So the slant height of the larger cone would be x plus 14.8. And that's it. So because the scale factor of enlargement is 1.6 recurring, if you multiply the slant height of the smaller cone by 1.6 recurring, it'll give you the slant height for the whole cone, and that's also equal to x plus 14.8. So that's our equation. Now let's solve it. So let's take away x from both sides of the equation. On the left hand side, we'd get 0.6 recurring x, and on the right hand side we'd get 14.8, and then we just need to divide both sides by 0.6 recurring. And it is a calculator question. Yes, it is this time. So we're going to divide both sides by 2/3, or 0.6 recurring. So if we divide the left hand side by 0.6 recurring, we just get x. On the right hand side, if we do 14.8 divided by 0.66666 and so on, we get an answer of 22.2. So that means that x is 22.2 centimeters. Okay, and this is fantastic because now we know the slant height for the smaller cone and for the larger cone, and that means we can calculate the surface area of this curved face of the frustum. So let's do that. So let's do for the smaller cone. I'm just going to change color bank here to blue. So for the larger cone, we're going to do pi RL, pi times the radius of the base, so that's pi times the radius of the base, which is 35, times the slant height of the larger cone. So we're going to do 22.2 plus 14.8, and that's equal to 22.2 plus 14.8 is equal to 37. So that's going to be pi times 35 times 37, and that'll give us the area of the curved face of the larger cone. And we're going to subtract for the smaller cone pi times the radius of the base, which is 21, times its slant height, which is 22.2. And when we work that out, let's see what we get. And again, it's a calculator question. So pi times 35 times 37, subtract pi times 21 times 22.2 is equal to 2,603.751991 centimeters squared. So that's fantastic. We've now worked out the area of the curved face of the frustum. Now we just need to work out the area of the circle on the top of the frustum, the area of the circle at the base of the frustum, and then add them all up. So let's do the area of the circle on the top of the frustum. So that's pi times the radius, which was 21, so 21 squared, and that's equal to 441 pi centimeters squared, or as a decimal number, that's equal to 1,385.44236 centimeters squared. So that's the area of the circle on the top of the frustum. In terms of the area of the circle at the bottom of the frustum, that's got a radius of 35 centimeters. So we're going to do pi times 35 squared, and that's equal to 1,225 pi centimeters squared, or as a decimal number, 3,848.451001. And then if we add them up, then that'll give us the total surface area of that frustum. So if we do our 2,603.75 and so on, plus 1,385.44 and so on, plus 3,848.45 and so on, that'll then give us our total surface area. So let's do that. And that's equal to 7,837.645352 centimeters squared. And I'm just going to round that to 3 decimal places. That's 7,837.645 centimeters squared to 3 decimal places. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on the surface area of a frustum. I really hope you found this video useful. If you have found it useful, please like and please subscribe to my YouTube channel. Also, if you need any extra help on the surface area of a frustum, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 314A, there's a dedicated video tutorial there on the surface area of a frustum. Alternatively, you can scan this QR code. But again, I really hope you found this video useful. If you have found it useful, please like it, please subscribe to my YouTube channel, and please recommend it to any friends or teachers and so on that might find the website useful. Thank you, cheers, bye.